Good to have you back. Today's lesson, molar mass calculations. Now, I am assuming that you know the definition of mole and what molar mass is and the difference between atomic mass, AMU, this is atomic mass unit, and molar mass, which is MOL, which is mole. That's the standard unit to measure the amount of a substance, okay? I wrote down a few information here as a review for you. But I also wanted to make sure that you do remember it. 1 mole of any substance contains this number, 6.02, rounding it up, times 10 to the 23 elementary particles. This number, a very famous number called Avogadro's number, okay? And that is what we are using as a bridge factor between the atomic mass unit and molar mass, which end up being the same. The molar mass was a man-made, basically. The atomic mass was the actual atomic weight of a given element or particle or atom, right? Obviously, a given atom. But the molar mass was this bridge was created so that we can go from this small particle, because it cannot be used in laboratory in terms of weight, to something that we can measure. Chemists can do work in terms of weight that is tangible and it's big enough that you can actually do experiments. And that's what the idea of mole came in, and therefore the calculation for molar mass. All right, now we're going to go through and we're going to do calculating 3-4 examples of molar mass for different compounds or elements, and then we go from there. All right, the first question is this compound C₁₂H₂₂ and O₁₁. Okay, so let's go ahead and let's first of all write up what we have. We have 12 carbons, we have 22 hydrogens, and we have 11 oxygen. All right, for each one, we need to go ahead and look at the periodic table and look at the atomic mass, which that's what we're going to use for each of these elements, and then come back and then do the math. So the carbon, hydrogen, and oxygen, let's go to the periodic table quickly. So here's a periodic table of elements, and I want to make sure that you see this. Now, here is, let me click on carbon, and the first thing that you see is the atomic mass on top. Now, how you read that on the table is you're looking at this number at the bottom of the chlorine, the name of the symbol, okay? Atomic number is on top, but the atomic mass is this number at the bottom, which is the biggest number, 35.45, and that is the unit, right? That's what we're going to use for this one. And of course, that's an example, but we want carbon, we want oxygen, and we want hydrogen. Hydrogen is up here, and we go ahead and we find oxygen. It's right there, oxygen. All right, so we have all of those, and we can go ahead and find each one of them. We have carbon, which is 12, if you can see that right up there, or you can actually zoom in and get that right there. Oxygen is almost 16, but let's call it 16, and hydrogen is 1. So we're going to go ahead and plug these numbers in and do the math. So let's go ahead, do that. So we're going to go one at a time. 12 times, and that's 12 is being multiplied by the atomic mass of each of these elements. So 12 times 12.0, 22 times 1.0, and 11 times 16.0, and then do the math. That's 144 gram, that's 22.0 gram, and 176.0 gram. So this is the individual molar mass for each of the elements in this compound, but when you add them all up, you'll end up getting the total molar mass will be 342.0 gram. Okay, that's how you calculate the molar mass for this one. All right, let's look at the next one. So here is the next compound. This is the ammonium sulfate. We want to find out the molar mass for this one. Now, don't worry, you just have to make sure that you count the proper number of atoms for each one. So we're going to go ahead and rewrite. So how many nitrogen do we have? This is 2 outside of this bracket, so there will be 2 nitrogens. How many hydrogen? 2 times 4, that's 8. That's 8 hydrogen. Then here we have 1 sulfur, and then oxygen, we have 4 oxygen. That's what we have, okay? And then we're going to go ahead to the periodic table and extract all the atomic mass for all of these and then write them all up. But I'm going to leave you do that, but it's very easy. So 2 times atomic mass of nitrogen is 14. 8 times 1, that's the atomic mass of hydrogen. 1 times 32 is the atomic 32.1 gram. Let's be a little bit more accurate. That's the atomic mass of sulfur. And 4 times oxygen, 4 times 16.0 gram. That's the atomic mass for oxygen. And then you have to do the math. So that's 28.0 gram. We have 8.0 gram. We have 32 times 1, that's 32.1 gram. And then we have 4 times 16, which is 64.0 gram. All right, now that we have this, we're going to add them all up, and that would be the total molar mass. Molar mass equals to, when you add them all up, you get 132.1 gram. All right, that is the molar mass. By the way, it's gram per mole, right? That's what that is. That's the unit of molar mass, right? So be aware of that. Okay, let's do another example. So the unit of molar mass, which is mole, it's actually at the end, you'll end up using gram per mole. That's what you will use for the molar mass when you are doing the calculation. Make sure you know how to do that, okay? That's gram per mole. It goes from, because that tells you however much the weight is per 1 mole. That's what that molar mass means, okay? So be aware of that, and I have explained the atomic mass as well. Okay. Here's another example. This compound is a hydrate compound. The name of this compound, you can actually practice that, is a copper nitrate hexahydrate. That's what that is, okay? But that's okay if you don't know the name. Right now, we're just going to calculate the molar mass. Again, we're going to write up all the elements and atoms in here to see what we have, and then we go through it. First of all, we have copper. This 1 copper we have. And then 2 nitrogens. We have 6 oxygen plus another 6 oxygen there. So we have 12 oxygen. So be careful with that. We have 6 from here, and then we have 6 from here. 6 oxygen and 6 oxygen, okay? So be aware. And then we have 6 times 12, which is right there. That's 12 hydrogen, okay? So we also have 12 hydrogen. Okay, so let's now go ahead and find the atomic mass of each one. That's simply, you're going to go to the periodic table and find it. So first one, the copper is heavy, 1 times, that's 63.5 gram. And we have nitrogen, we already done that, 2 times 14.0 gram. And then we have 12 times 16.0 gram. And the 12 hydrogen, 12 times 1.0 gram. All right, let's add them all up. This is 63.5 gram, 28.0 gram, 192.0 gram, and 12.0 gram. Total molar mass is 295.5 gram. Okay, that is the molar mass. All right, and remember, again, this is the actual unit on this one is gram per mole, but we use that so that we can do the calculation when we are doing the a dimensional analysis, but the actual unit of molar mass is gram per mole. Okay, so that's 295.5 gram per every mole of this compound. All right, so that is it. Three examples, very interesting examples, all of them. Make sure you check out the quiz in a description. Make sure you take that quiz as a review or as a practice. It doesn't matter, to make sure that you understand these, but make sure you go through and make sure you understand how to do the calculation for molar mass, because it's very important. We're going to continue with this. Until next time, check out the next video in the series. Okay.